Okay, folks, so we're continuing to climb in the Southern Appalachians to understand the forest types that are here. So the last lecture, we looked at the lower elevations. Now we're going to look at the high elevation forest types that we can find in Southern Appalachians. So this, again, will review kind of the factors, the different environmental factors that shape the forest types in the mountains. And then today's lecture focuses on high elevation forests, so 4,000 feet up above 6,000, focusing on three main types: high elevation red oak forest, affectionately known in the business as HERO, northern hardwood forests, and spruce-fir forest. We'll also take a look at places that don't have forest and talk about why we might find different plant community types that don't have a closed canopy forest. So back to Whittaker's diagram from 1956. Remember, he predicts forest types based on elevation and topographic position. So in our last lecture, we focused more on these lower elevations, right? Down here below 4,000 feet. This lecture focuses on the higher elevations, which he doesn't do as good a job of because there's other factors in here. So this might be the place that we call boreal forests, but also beech types, which we call northern hardwood forest. And we'll also look at HERO, which kind of falls in this part of the spectrum. So these three forest types that we're going to focus on: northern hardwood, high elevation red oak, and spruce-fir forest. If you look at Emma Lucy Brown's diagram, right, she groups all of these into oak-chestnut forests. And so, you know we can recognize more forest types than what she recognizes as oak-chestnut forest. And again, depending on the elevation, moisture, and topography, those are the major factors that really separate out these forest types. So we're going to start again with a general photo that just gives you a sense of the structure and topography and the physiognomy of these forests. So this is a photo from the profile trail at Grandfather Mountain, looking at northern hardwood forest, and this is a really giant Aesculus flava, yellow Buckeye tree. And so northern hardwood forests are found, in this part of Whittaker's diagram, right? So above 4,000 feet. He lists them as beech forests and says is a mesic type and a sedge type. And so this is kind of where we're finding them. So above 45,000 feet, but fairly protected sites, right? So either flats or sometimes the highest part of the cove. You can see this forest here, again, on the profile trail at Grandfather Mountain, is fairly flat. So not very steep, somewhat protected for sure. And when we look at the species composition of northern hardwood forests, here in North Carolina, we call these the southern northern hardwoods. So the northern hardwood forest, it's named after the forest types that we'll actually talk about next week of New England and the Lake States. And so we classify those as the 3 Bs, and that would be beech, birch, and Buckeye. And then in the south, we also add sugar maple. So like I said, these forests are found on protected slopes between 3,500 to 5,000 feet and consist of beech, birch, Buckeye, as well as sugar maple. And the structure is often similar to cove forests. Sometimes they even do have a bowl-shaped depression. They do often have a rich understory, but there are not as many species that can live in the canopy at these higher elevations. So they tend to be less diverse than the rich cove hardwood forests that are at lower elevations. But there are definitely people who would argue that a northern hardwood forest is just a high elevation version of a cove forest. We also have recognized different subtypes within northern hardwood forests, and 2 of them that we'll look at today are birch boulder fields and beech gaps. So I'll show you what those look like, but they're generally fall into the classification as one type of northern hardwood forest. So some important species first. The components for northern hardwoods are yellow birch, Betula allegheniensis, and we talked about sweet birch in the last lecture, right? Yellow birch tends to be a higher elevation species, and you can see it ranges farther north. In the continental United States, it does have these lenticels, are pretty frequent. The bark can be fairly shiny. And yellow birch has this really amazing ability to send roots down around whatever it sprouts on top of. And so sometimes that can be rocks and boulders. So that's why you have a birch boulder field as a subtype. But sometimes it could be a stump. So in this case, we have a stump. This is taken at Black Rock Mountain State Park in northern Georgia. And this yellow birch is sent, as a seedling, it sent roots down into the soil as it sprouted on top of this nurse log. And then over time, the log rotted out from underneath it. So it sort of has this tiptoey kind of look. So that's something, yellow birch is not the only species that can do that, but it's the one that's most frequently seen. And you can see this, this was taken on the Tanawa Trail, not far from the Blue Ridge Parkway, going up towards Rough Ridge, if you've been up there. And you can see these are yellow birches, right, that are in a boulder field forest, right? So this makes yellow birch a really strong competitor when you have boulder fields, right? So areas with really large numbers of rocks, you can see that, you know, the soil surface has a lot of exposed rock. And not that many species can just germinate on top of rocks without soil, but yellow birch is one of those. Also in the northern hardwoods is American beech, Fagus grandifolia. You can see this is a little more widespread than yellow birch, certainly ranges further south. And this species should be very familiar to you. And sometimes you have an area that's almost 100% beech, and we call those beech gaps. It is a type of northern hardwood forest. And so Elk Knob State Park, which is kind of northeast, actually I'd say like, yeah, mostly north of Boone. Really nice, really pretty park that's fairly new. It's located in the Amphibolite Mountains, which have less acidic soils, and so beech does well in those kinds of environments. And you can see this is actually taken on the same trail, but this photo on the left is the lower elevation forest, and it is 100% American beech. This is taken in early spring before the trees have leafed out. And then same day, same forest, a little bit higher on the trail, you can see that as you get towards the summit of Elk Knob, this forest is a little more subject to the environmental conditions like storms and winter winds. And so the forest takes on this kind of gnarled appearance, but it's still American beech. So pretty startling to see how a forest type with largely the same species can look very, very different depending on environmental conditions. Our other bee species in northern hardwoods is Buckeye, in this case Aesculus flava. And you can see that, right, it has this typical Buckeye, right, opposite palmately compound leaves. And these are the fruits that should be familiar to you. Buckeye ranges from western North Carolina up into the southern Midwest. And this is a huge Buckeye tree that's on the profile trail at Grandfather Mountain. And then lastly, sugar maple. So this is a northern species that is the source of maple sugar and maple syrup. You can see this is an enormous one that I found, and this has a pretty familiar shape to you. It looks a lot like southern shug, but it is the species that's found farther north and tends to get much larger. So this is Acer saccharum. And northern hardwood forests are pretty interesting and unusual forest types. We have, they are home to, this is my gratuitous animal plug, they're home to Carolina northern flying squirrels. And so this is a federally listed subspecies of flying squirrel. And they're not very competitive with southern flying squirrels. So their niche is northern hardwood forests. These guys are a little bit smaller than southern flying squirrels. And they subsist on the lichens that grow on yellow birch trees. So, and also some fungi and truffles that grow on red spruce roots. So I'm going to click this link here. See, yeah, so here's a picture of them. They're extremely cute. Endangered species, and you can click that link to get more information. This is actually one of our students who's an alumni, Summer Higdon, and she spent a summer working with a graduate school student at Virginia Tech trying to use telemetry and tracking to trap and understand the range of northern flying squirrels in some of these northern hardwood forests. But that is a species, if you're trying to find that particular species, you need to know the forest type and you need to know where to find it so that you can identify potential habitat. Yes, and there they are. So let's shift gears a little bit and talk about Hero, or high elevation red oak forest. This is a beautiful section of it on the Appalachian Trail. You can see the white rectangle, and this is kind of near Little Hump Mountain, a little bit closer to Carver's Gap on the North Carolina-Tennessee border. And I was out there on a really horrendous, beautiful but horrendous day weather-wise, where we were at 6,000 feet. It was the end of July and sheets of rain and temperatures down into the 50s. So this high elevation red oak forest, you can see, right, has mature kind of gnarled oak trees. Here's some that are found here, and the canopy is almost entirely northern red oak, so that's pretty unusual. When you're looking at the Whittaker diagram, we talked about the Oak-Chestnut Forest and the oak hickory forests that are found at lower elevations. When you get into higher elevations, there's not very many oak species that can hack those harsher conditions, but red oak is one of them. And so we see this at the higher end of the elevation spectrum, found in open slopes, you know, kind of drier sites. Often those forests are more open and like parks, right, without a huge understory. And that's partly just because of the exposure and harsh conditions, right? The canopy trees are kind of stunted and they're spaced farther apart. And when you get into the northern slopes, right, it sort of segues, right, if you imagine this goes into the northern hardwood forests. But so if you're in a northern hardwood forest that's like a protected bowl, then you get out to an open slope. If you looked at the canopy trees, I love doing this exercise where I have people identify the 10 largest trees in their immediate vicinity. And so you can go from a protected site where you've got, you know, beech, birch, buckeye, sugar maple, and also northern red oak, and then go out on a more exposed open slope, and suddenly all 10 out of 10 trees are northern hardwood, or 10 out of 10 trees are Quercus rubra. That's your transition, or the ecotone transition between two community types. So as far as disturbance goes, these are forests that are shaped by harsh weather. They're definitely more exposed to winter storms. And we also think there's some element of fire that helps knock back the competition. That seems to be a general theme for oaks in general, because they're not as competitive. And so having some regular fire does help with other competing species. And so if we look at this, right, it is northern red oak has a very broad distribution. It's found in lots of different forest types and is a major component of montane oak forests. So at the lower elevations, we see plenty of Quercus rubra, but as you get higher, you'll notice that if you look at all the oaks that are around you, you'll have mostly just Quercus rubra. In the weekly, he classifies red oak at higher elevations as a different variety. Sometimes this is called Quercus rubra var ambigua, but also there was even a pretty heated discussion on Facebook recently. Another name that I've seen kicked around for this species is Quercus rubra var borealis. So there's still a lot of work being done to figure out that, right? So I've seen it called Quercus rubra var borealis, or just plain Quercus ambigua. In fact, I have this print. This is taken from Francois Andre Michaud's North American Silva. This is a print of Quercus ambigua. It's labeled gray oak. And you can see that it looks similar to Quercus rubra, but it's got some key differences. For one thing, the sinuses are larger, right? So if I go to the next slide, right, this is Quercus rubra, right? Classic. Okay, the sinus only comes in about a third of the way, closer to half for Quercus ambigua. You can also see that the acorn caps are a little bit deeper with more of those overlapping scales. So that's another difference between species. So they think that it's at least a variety and possibly another species. This Quercus rubra, this is the classic Quercus rubra here with the leaf. And often this is what I was talking about, this park-like setting, right? So there's an understory of ferns here and then kind of scattered gnarly trees. This, I'm gonna play this for you quickly. This is a photo I took on the slope down, going from Mount Mitchell down to the Black Mountain campground. And so it's a long trek and it goes through some beautiful hero forest, high elevation red oak forest. And so I wanted to show students, you know, I could take this photo, but it was really impossible to show just how huge this tree was. So I thought I was doing a self-take, but it turned out I was doing a time-lapse photo. And so I ended up doing an unintentional time-lapse, which turned out pretty funny. Okay, and moving on. So if you go up to the highest elevations in the mountains, you encounter this amazing pointy evergreen forest. So this is taken on the Black Mountain Crest Trail up near Big Tom and Mount Craig. And if you're inside of this forest, it looks very dark and spooky. I always think of Robert Frost's Stopping by the Woods on a Snowy Evening poem, right? The woods are lovely, dark, and deep, but I have promises to keep. And you can see this is all an evergreen forest. This is the trail that goes down to the Black Mountain Campground from the top of Mount Mitchell. So I was up there exploring that. And so this is our Spruce-Fir Forest, which is a forest type that is found at the highest elevations around the world that are still forested. And in North Carolina, these forests are found at the highest elevations, so above 5,500 feet. And so Whittaker has them marked as boreal forests on his little diagram here. Now, when you get to you'll notice that boreal forest he has across this entire topography. And that's because at the high elevations, topography is not as important. You're in, you know, kind of clouds, and so you've got lots of fog drip and cloud drip that's there, so moisture is not really limiting. Generally, these forests have a dense, very even-aged canopy, so all the trees are about the same age. And fog drip is a significant source of water, so there is plenty of precipitation, but there's also constant moisture in the air. Generally, with a thick, evergreen, even-aged canopy, there's not a whole lot in the understory except where there's openings. And this forest type is really threatened by climate change, as well as an invasive insect called the balsamolia delgid. I'm going to click on this. Oh, this is some wildlife found up at the start of the trail. So that's the beautiful song of the winter wren, and that is very frequently heard at those high elevation spruce-fir forests. So just a really pretty warbling call. So here we have boreal forests at the top of the Whittaker diagram. So quick tree trivia, I've already said the answer. What is the highest peak east of the Mississippi River? So the answer to that is Mount Mitchell, 6,684. 6,684 feet. And you can see that we have quite a few of the tallest species. These are the top 10 tallest species east of the Mississippi River. So we have Mount Mitchell at the top, but the Black Mountains have several of the highest, right? So that includes Mount Craig, also Balsam Cone, also Silo Knob, right? Mount Gibbs. I'm surprised that Big Tom is not in here, but it's not. So the highest forests and mountains in the southeastern United States are in the Black Mountains. There's some large ones in the Smokies, and also in the Great Balsams. So Mount Washington, which seems like a really, really high peak, it's much farther north, so you do get above climatic tree line there. But Mount Washington in New Hampshire is actually smaller, not as steep, as high as these 6,000 footers. So just plotting out and looking at this unfortunately blurry map from the Southern Appalachians, you can see the black areas are areas that are designated. This is where red spruce and Fraser fir, the Spruce-Fir Forest communities occur. So you can see there's some at Mount Rogers, Grandfather Mountain's got a bit, Round Mountain, Black Mountains, which is where Mount Mitchell is, the Smokies, and the Balsam Mountains. So how do these forests get here, right? Those are too far for those species to really disperse. And the answer to that story is that these are forests that are remnants from a past climate. So at one point during a time of cooler climate, this forest type was really widespread. And it was found all over the Southern Appalachians and then bridged up into the northern part of the Appalachians. So at a time of cooler climate, that forest is way more extensive. But now that it's warmed up, we just have these little remnant populations that we call sky islands. So if I take my leaf collection again, I can see the spruce and fir are here at the center. And then I've got a few other species. These are mostly shrubs that can be found at these high elevations. But just to show you, you know, so fog drip is a significant source of water for these forests. And then this is taken up at Roan Mountain. And you can see that this even age, right? So we've got a canopy of trees. Some of these are dying back. And then you've got this whole understory where there's light. And you can see all those baby fir trees regenerating in the understory. This forest has two important species, Picea rubens, right? Red spruce, which we learn in lab. And you can see it's at the southern end of its range in North Carolina. It's way more widespread as you go up north and into New England and Canada. And interestingly, its niche is slightly lower in elevation than Fraser fir. So red spruce is generally found, you know, you can start spotting around 4,000 to 4,500 feet. But by the time you get above 5,000 feet, it's much more fir than there is spruce. And then it grades into northern hardwood forest. So we call that transition area between two different forest types the ecotone. And sometimes the ecotone is very, very easy to see, and sometimes it's more difficult. Because spruce is an evergreen tree, it can be easier to spot those ecotones, and I'll show you a picture of one of those. Red spruce also grows in bogs in the far north, so that's another niche for this species. And you can see, you know, some hallmark of red spruce. You can see the little sterigmata, the little pegs that the needles perch on. You can see that spruce is sharp, so it's got pointed foliage. And then also these cones have rounded cone scales, and they hang down from the branches of trees. So you can sometimes spot, it's also got dark green foliage. Looking at Fraser fir, Abies fraseri, you can see the cones perch on tops of the branches. So that's a major difference in telling those two species apart. They can be, you can get a hang of identifying them at a distance, but for now, they can look fairly similar when they're side by side. So if you look at the range map and compare, Fraser fir has a much more narrow range than red spruce. It is a very narrow Southern Appalachian endemic, so only found in, you know, just over a dozen counties in North Carolina and Tennessee. That county yellow dot in Georgia, I think, is false. I've been told that Fraser fir doesn't occur in Georgia, but it does occur in 2 counties in Virginia. And again, those cones are held upright in the branches, so that makes it easy to tell. This photo was taken at Clingman's Dome, and you can see there's a huge amount of die-off. So that's Fraser fir that's dead in the foreground. So it's being impacted by an invasive insect called balsam woolly adelgid. So similar to hemlock woolly adelgid, but specific for Fraser fir. And this photo I took, this is in the Black Mountains again, and I'm headed towards Big Tom, looking back towards Mount Mitchell in the highest part. You can see these big swaths of dead fir, right? And where I'm standing, it's actually quite open because the fir has been killed off by balsam woolly adelgid. So it tends to travel in waves and causes these waves of fir mortality. Another interesting thing I'll point out with this photo is that you can see the direction that the weather comes by this Fraser fir that's here on the slope. I'm here and it's not a very windy day, but you can see that all the branches that would face into the prevailing winds have been pruned off, probably by water and also ice freezing in the winter. And so they tend to have this, what we call flag form. And when you're in the middle of this area, right, of die-off, you see massive, like all the trees in that general vicinity are dead. And so that allows for kind of uneven generation, but you can see it kind of moves up and down the slope. So that's part of the reaction of Fraser fir to this invasive insect. And again, you can see the cute little cones that are upright on the branches. These are cones that shatter, so you don't find intact cones in the ground. The scales come off and fly away on their own, and then all that's left is the center stem. And then you can see this is a sort of a regeneration photo also taken up at Roan Mountain, where one of the mature trees has fallen down, right? And it's left open a gap, and you can see all these baby fir trees that are regenerating here to capture that gap. So lastly, I want to spend just a couple of minutes talking about non-forested plant communities, right? So, and reasons, why might we not have non-forested plant communities in the mountains? So you might think it is because we're above climatic tree line, but that is not actually true. There's been some studies and mathematical work done on climatic tree line, doing an extrapolation by latitude and other tree lines that are farther north. And so if you do that extrapolation, the paper that was published said that climatic tree line in North Carolina would be about 8,000 feet if we had mountains that tall, which we do not. So there are various reasons why you may have no plant communities in certain areas. And so we'll talk about examples of them through these 4 different forest types. So high elevation rocky summits, also called HERs, granite domes, heath or shrub balds, and then grassy balds. So let's look at each of these in turn. These are really cool communities. So high elevation rocky summits, this is a former student who is rappelling down to survey for rare plants and a high elevation rocky summit. So this is an example of what I like to call extreme botany. And this is a high elevation rocky summit at Wiseman's View in Linville Gorge. You can see that there's a lot of exposed rock here and really only little pockets of soil. So one of the notable things about high elevation rocky summits is that there's lots of crevices and places that will accumulate soil. And so you do have a good bit of vegetation here. It's just not continuous and it's not a closed canopy. You can see in this photo on the close-up that we have table mountain pine, and I can tell that from the heavily armed cone and the general shape of it, and the fact that there are several cones retained on the branches. And here are a former graduate student and former undergraduate doing their survey for Blue Ridge goldenrod and other rare plants that grow in these open areas. So you might imagine a little plant that's not very competitive might like these high elevation rocky summits because they've got little pockets of soil, and so they might be able to compete there where they wouldn't be able to in a closed canopy forest. You can see this high elevation rocky summit is surrounded by Spruce-Fir Forest. So next, let's talk about granite domes. So these also have lots of exposed rock, but unlike high elevation rocky summits, these are smooth, right? Relatively smooth. And so the vegetation kind of develops in mats and also some cracks as well, but it's a very different look to that community. And then I'm going to show you heath bald communities. So this is maybe a little bit similar to the granite dome on the previous slide, but you can see this is actually a ways off. This is taken at Mount LeConte, looking across the valley, and you can see this flat vegetation is heath bald or evergreen shrub bald. So when's the last evergreen shrub bald we discussed? So it was Pocosin, right? So here on these very, very steep ridge lines, you don't have a lot of soil. There's really not enough soil for trees to establish. You can see they're down here lower, right, in these different fissures and valleys. But the place that's an open slope and on top that's very exposed tends to pick up these evergreen shrubs. And once they're there, they stay for very long periods of time. So this is a video that I took of inside of the heath bald, or actually on top, watching my students go down. This is a heath bald we had to crawl through to really get a sense of it. So I thought that was pretty funny. We'd taken our students up through this heath bald, and it was pretty awful to get there. We had to kind of crawl through these shrubs to get in there. This is what it looks like when you're inside. And then I was the last person to descend, and so I was trying to give people space, and I noticed that you could see where they are based on the movement of the vegetation. So these heath balds have like rhododendron and blueberries. Sometimes they're woven together with smilax. So in this case, we actually had to crawl through the heath bald. It's extremely dense vegetation. If you're lucky, you hit heath balds when the blueberries are ripe. And so that's a little reward for getting through the density of it. So this is a photo taken from Roan Mountain, North Carolina. It's on the North Carolina-Tennessee border, again on the Appalachian Trail. That's my older son that's there with me. So this is an example of a grassy bald community. So you can see it's this beautiful open grassland. They tend to have beautiful views. They're very popular places for people to visit. And this is a backpacking trip we did between Carver's Gap and 19E. So here's our tent, and then just an amazing afternoon with these open slopes. So, you know, you might think, okay, so are we too high? We know elevation is not the issue here. They've actually done experiments where they've planted trees on these grassy balds and they grow just fine. And so what we think is that these grassy balds were open because of past disturbance. So thinking about grazing from large mammals during the Pleistocene, so the Pleistocene megafauna, like giant ground sloths, bison, elk, right? So other species that grazed and kept these grassy balds open. Today we have to keep them open either by mowing or sometimes grazing. So there's a few of these grassy bald summits in North Carolina that have a tradition of grazing and that keeps them open. So just interesting to see that you can have these unvegetated areas of the mountains. And it's a little bit of a mystery as to why they're there. So I'm taking you back. This is a little bit of a joke. This last slide photograph, this is a Mount Mitchell sunrise. I was there at sunrise and that's what I saw. So just to quickly wrap up, we have high elevation forests in the Southern Appalachians. The vegetation that you find there depends on the elevation, the moisture, and topography. And, you know, a lot of the species that we see when we looked at all those range maps, one thing that kind of emerges is that many of these species are much more common to find in New England and Canada. There are some that are Southern Appalachian endemics, right? I might ask you to give an example of a Southern Appalachian endemic. And so that's a species only found in the Southern Appalachians. And so we think that, you know, during cooler climates in the past, for example, most recently the Pleistocene about 18,000 years ago, the species that we see here today as remnants, which were much more widespread. And so now we just have these little sky islands that have some of these boreal species. And we also find that there's patterns of species diversity. So as you get to the higher elevations, you're going to see fewer species. They're just not adapted for the harsh conditions that are found at those summits. And then you can also have examples of places that have a very steep topography, rocky substrates and not very much soil, high disturbance like things like ice and high winds and during winter storms. These are places that may not end up having forest, right? So they're open for various reasons, but not because we're above tree line. So Southern Appalachians, we are not above tree line. Southern Appalachians were never glaciated. So that's something to keep in mind as you try to sort through and understand these forests. And that's a wrap.